So the professor actually ran the car in there. He had the students build the models and made sure they're actually, ready to run in CFD. So it's just crazy to me because this car is built in a town with a population of 500 people with a true international effort.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we've got Cody Loveland joining us. And Cody has been involved in the motorsport fabrication industry for a number of years. I actually met Cody when we were over at Pikes Peak a fair few years ago, and we shared a workshop with him. And I got to see firsthand his work building the Enviate Hypercar. That was a car that competed in the unlimited class at Pikes Peak. Unfortunately, they had a few issues the year I attended and didn't really get a representative time on the board, and they've actually gone ahead and developed a Generation 2 hypercar. So in this interview, we find out a little bit about what goes into developing a car from the ground up, particularly for the likes of Pikes Peak in the unlimited class. There really are very few rules. Basically, as long as it's got four wheels, the rest is just about open. And here we also talk a little bit about the engine development, what powers the car, learning to build an engine or a combination that's going to work at the high elevation of Pikes Peak, and also the development of the suspension system and how that works and integrates with the aero as well, given that this has a downforce package developed by a Sauber F1 aerodynamicist. So this thing is no joke. Now, as part of this, if you go through this interview and you're interested in learning more, particularly around the suspension development side of things, we have got our suspension tuning and optimization course out, and that's available at hpacademy.com/courses. We'll drop a link in the show notes to that course as well. So this is perfect for those of you who may be thinking about making some fundamental changes to the suspension geometry, even if it's your stock standard road car that you want to compete at the racetrack in, or maybe like Cody, you're going down the rabbit hole of developing a complete clean sheet fresh build with no limitations around the suspension. In that course, you'll learn how the suspension design affects the way the car is going to handle, and how to actually make adjustments to the suspension geometry and then validate those using a nice simple spreadsheet that we've included inside of that course. Now, you can also, as a podcast listener, use the coupon code podcast75 at checkout. That's going to get you $75 off the purchase of your very first HPA course. All right, with that out of the way, let's jump into our interview with Cody now. All right, welcome to the podcast, Cody. Thanks for joining us today. And I think what I want to do is just get started with how on earth you learn to become a motorsport fabricator. It's one of those sort of jobs where there's not necessarily a direct career path, and a lot of people sort of fall into this vocation. So how did you learn to fabricate?
I don't know. I've got to ask myself that all the time. Basically, when I was 15, I was into mountain biking. I was, standard kid. And then when I turned 16, I discovered, cars. One of my first cars that I got into was just your average Honda Civic. It was 96 EK model.
Right.
I basically, I had a D series, didn't have the money to do a B series swap. And this would have been back, 2000, 2001, somewhere in there. So literally went down to Ace Hardware, picked up a bunch of threaded pipe fittings, and hogged out a flange with a hole saw and a drill press, and built my first turbo manifold. I believe I used a Saab, one of the turbos off a Saab. I don't even remember now. But a Saab turbo and FMU. I cut up a Dodge. It's actually probably worth a lot of money nowadays, but cut up an intercooler off a Dodge Cummins pickup truck and got 3 intercoolers out of it.
Sure.
So,
okay. Way to go.
And then it just kind of progressed from there. Fabrication, I kind of dialed in. It took about 3 years to really get decent at like turbo manifolds. And that's what lovefab started off as. And then it kind of grew into, you can build some great turbos, turbo kits. What about tuning? So then I got into the tuning side. And then from there, it's like, well, I'm bored. I've been beating on my stuff on the track for, 5-6 years. Let's take it to the next level.
So in terms of the fabrication, we'll get into maybe talking about the tuning as well, but with the fabrication, essentially what you're telling me is you're self-taught, there's no formal qualifications, no formal training that you've actually done to get to the level you're at now?
Correct. Yeah. So, I mean, back then, I don't think YouTube was founded in 2005, 2006. So like nowadays, if you want to learn something, you hop on YouTube and you go do it.
Yeah. I mean, it's a blessing and a curse. There's a huge amount of information on YouTube on just about any topic you might want to learn about. But of course, some of the advice is potentially a little bit questionable. So there's a bit of sorting fact from fiction, correct?
Exactly. So I guess that leads into the next thing. Back then, forums, internet forums, Honda Tech. What else was there? I don't even. Honda Tech is the one that comes to mind.
Yeah.
I mean, that place is brutal. So I remember the first few manifolds I did, and I knew I was doing something right because you attracted the big names. But they'd come in and be like, "Oh, it's Ray Charles," blah blah blah. But it's like, oh wow, all right. So I just kind of put on a thick skin and took it constructively. And all right, well, what can I do different? And I just started playing with settings in the welder, and yeah, there we go.
So at this point, are you MIG welding these manifolds, or are you TIG right from the get go?
So the first manifold I did was with a stick welder. Just
oh wow, okay.
Something, and this was the threaded Ace Welding, Ace Hardware fitting manifold, but it worked. It didn't leak. Definitely wasn't pretty.
I'm interested to know at a point where you're sort of looking at this EK Civic and you're like, hey, you know what? I want to add a turbo kit. A lot of people would be in the situation where they're weighing up, well, I could buy, I guess eBay turbo kits probably maybe weren't thick on the ground back then, but looking at a commercial kit versus the cost involved with buying some welding equipment and kind of fabricating this yourself, what was the sort of the way up there in your mind, or is it just a no-brainer?
I mean, basically back then, so my stepdad, he loaned me some money, and I went and bought a TIG welder with that. And I was like, I'll pay you back 20%. He's like, all right. So basically, by the time I figured out how to use it, I had him paid back in less than 2 months. So it was pretty cool. But back then, I mean, eBay was around, but there was definitely not any China knockoff stuff. So
yeah, there
was no cheap way to do it. I think with the D series stuff, they would do like the HF manifold. I don't know if you remember the 88, 89 Honda Civic EFs. They had like a cat that bolted to like almost a turbo manifold looking thing. You would basically drill that manifold out and bolt like a 14G or something to it. So that's the route they went. But I mean, back then you couldn't just go buy something. I think RevHard was around, so you could do that. But I mean, at the time that was like $3,800. Here I am, a 16-year-old kid. I just paid $3,800 for my car.
Yeah. Yeah, I mean, I think a lot of people that are maybe just getting into the automotive performance scene today don't know how lucky they are with the wide availability of parts. And I mean, I mentioned eBay. It's one of those situations where there's a lot of absolute junk on eBay, and there's jokes about all of that. But occasionally there is some actual cost-effective equipment that kind of does the job. Maybe it's not the best of the best, but again, if you've got a budget, you've got to work to what's available. So it kind of is what it is. Moving forward, once you sort of got found your feet and you'd sort of mastered the art of welding. You mentioned lovefab, one of the businesses that you are running, and kind of we really want to talk today about probably what you're best known for, which is the Enviate Hypercar. And I was fortunate enough to see this run back at Pikes Peak a few years ago when I was over there running another car, and definitely one of the fastest cars in the unlimited class. Can you give us maybe the high-level view of what went into that Generation 1 Enviate Hypercar and why you decided to go so extreme? I mean, most people, if they want to take on Pikes Peak, might maybe do an engine swap on an existing chassis, maybe modify the suspension and send it up the hill. You decided to start with a clean sheet of paper and build an entire car from scratch, it's a pretty bold move.
And on top of that, I somehow attracted F1 talent as far as the engineering team. So that helps.
Yeah, definitely.
So basically I just kind of looked at, what was available, what I could afford, and what I could build with what I could afford. So, at the time I could have went and bought, Corvette or something and tossed a cage in it and just ran it, or another NSX. But weight is the enemy. And when you build a street car and turn it into a track car, no matter what, it's going to be heavier every time than a dedicated track car. So, or race car, I guess. So kind of just went from there. And then, let's see. Yeah, the Gen 1 Enviate was still very much a budget, and I used a junkyard 5.3. It used a 30-year-old Porsche Gearbox. Definitely had a lot of good support. At the time, Vibrant was title sponsor. We got a ton of fabrication components from them, a little bit of cash, which couldn't have done it without them. It was awesome. And then, a ton of other supporters at the time, too. So it just kind of all came together. It's like, I could build a Corvette, sign it up, self-fund it, or I could build something wild and attract additional help. And as long as I know I can follow through and actually do what I say, it's going to go well.
All right, well, let's come back a notch, because obviously we've got an audio only podcast here, so it's a little bit difficult for our listeners, if they haven't seen this car, to get a sense of what it is and what it looks like. So you mentioned 5.3, so you're talking basically the cast iron block, essentially 5.3 LS style V8, but turbocharged, twin turbocharged from memory. Layout of that. You talked about the Porsche transaxle. So give us a bit more of a sense of how the car was laid out. Okay,
so it was what was it? An LM4, which I believe came in those funky Chevy SS pickups, and I think a Trailblazer, if I remember right. So it was actually aluminum block, and that's why I did that.
Oh, okay. These are the we don't get them here in New Zealand. We're not that lucky, but these are the ones that we hear about, where you can pick them up for $350 from a wrecker and go and chuck a turbo on it and make 1,000 horsepower all day long. That's the sort of that's the dream, right? Is that what I'm sort of hearing?
Even better, we got two of them for like $450.
Okay, yeah, wow.
And then we tossed. I'm trying to remember what the components were. It seems like yesterday, but then it was actually like 6 years ago. So it's been a minute. So I mean, we built it. It had head studs, it had pistons, valve springs, all that, but it was still, essentially just stock 5.3. Twin turbo had Garrett. We had Garrett GTX 3576s on there, so relatively small, but it did well. That car probably only made 800 wheel, maybe 850 tops. So previously, like during initial development, like the previous year, because I had a car running for a year before we went to Pikes Peak. We had an LQ9 with a 6-liter iron block in there. That thing was a freaking monster. And in hindsight, I would have left that in there. Damn the weight. Sure. So, 12 pounds of boost on pump gas. It made almost 800 wheel. And it just ran all day long. Just ran. So, but people that don't know, 2017, we made it literally the last corner, and the car shut off for about 45 seconds. In retrospect, the head gaskets were so blown that the coolant, the water, doused the spark plugs, and it took 45 seconds for the plugs to dry off enough to run again. So, and then Paul Girard, the driver, he did a reverse bump start, and he brought it home. But I mean, even then, I think we still finished with like a 10:19, I think, 10 minutes 19. So we would have been deep in the nines for that one.
Yeah. A bit of a case of what could have been.
Oh, I think that's racing in general.
Yeah, of course. All right, so can you give us a sense? You've said 800 wheel horsepower. What sort of weight are we talking here with a full tube frame chassis?
I believe that year the car was 2,150 pounds, roughly. Okay,
so in metric, just a touch under 1,000 kgs. Is that with driver or is that beer?
With driver, it was 2343, so just touch over 1,000.
All right, so you're building a car as well for essentially unlimited class. I think from memory, the rule book's pretty thin. Basically, as long as you've got four wheels, the rest is just about up in the air. Aerodynamics is obviously a key aspect of this, particularly as the power levels go up. Trying to get that power to the ground becomes more and more of a challenge. So can you talk us through the aero development on that Gen 1 car?
Yeah, so Sebastian Lamore reached out At the time that he reached out, I had the car running in tube chassis form, which was awesome.
Okay.
So he reached out
So
and said, "Hey, do you want some?"
Sebastian's ex Sauber F1.
Yes, yeah, Sauber F1, which became Alfa Romeo. So
Yeah, okay, and he's an aerodynamicist for Sauber / Alfa Romeo.
correct. Yep.
Okay.
So then he spearheaded the whole design. I just told him, like, you give me a design. I have I can take it tangible. I can make it into a real car. So he did. He designed it. He ran it through CFD. That was done through University of Valencia, actually.
Okay.
And they actually the classroom did a study on that. So the professor actually ran the car in there. He had the students build the models and made sure they're actually, ready to run in CFD. So it's just crazy to me because this car is built in a town with a population of 500 people with a true international effort. So anyway, they ran through the CFD models, make a bunch of tweaks, and Sebastian's like, set it up like this. I said, okay. So whole bunch of carbon fiber, whole bunch of epoxy, and there's probably 5,000 hours into that car, if not more, probably more.
Yeah, I think it's easy for people to look in from the outside and maybe overlook just how much time goes into building something like this, because, of course, not taking away from Sebastian's efforts, but essentially doing the modeling and the design in the virtual world is kind of almost the easy part. And once that's all validated and he's got a design that he thinks is going to work for you, you're the one who got the hard task of then actually turning those virtual models into something real, correct?
Correct. Yeah, absolutely. And yeah, it's not to belittle his efforts. I mean, I reckon just on car one, he had 1,000 hours into it.
Yeah, wow.
And that's on top of his full-time F1 career. I mean, he didn't do it at work. He'd come home. Those F1 guys, they don't do it. They don't do it 9 to 5. They're 16, 18 hours. So that's huge. I mean, that's and the base look of the car remains even to this day. A couple different wing packages and stuff. But yeah, I mean, it's a ton of work and a ton of money to get it done. So it's why did I do this again?
So it's one thing to model and validate the aero package in CFD, but obviously there can be some variations to how actually things work in the real world as well. Was there any sort of real world validation of the aero package? Were there any changes? You said this car actually ran for a year. I think you mentioned before it went up Pikes Peak. So it sounds like you had a bit of a chance to shake it down. So what did you actually find in terms of how well that aero package worked? Did it just match Sebastian's sort of expectations, or did it need some tweaks?
The first time I ran the car with full aero, we broke the suspension. And then we ran it again and we broke the suspension again because apparently the aero is working very well.
So more downforce than you'd anticipated, essentially. That's what you're saying?
I mean, yeah, it kind of comes down to the design side too. So I leaned on my team to help me figure out material thicknesses and whatnot for push rods and suspension and control arms. Yeah, I mean, the first time we hit 120 miles an hour with the car, which was 200 kph your units. One of the rear push rods just completely collapsed. You're skidding down the track. You can't turn. You can't stop. You're just along for the ride. So the first major time I was actually comfortable with the car was at Road Atlanta, which is not a track you want to go to unless you're confident. Sure. And broke the front wing off. So
okay.
It actually cracked the mounts, but so it was able to hang on. So basically, what I did was I would just drive the car to 100 miles an hour, maintain, and basically just not use the brakes. And I was still able to turn like a minute 35, just messing around. One of these days, I do want to go back with a properly sorted car because that's absolutely brutal there.
Yeah, no doubt.
But as far as like balance and stuff, we were fighting front balance. We needed more front downforce almost the entire time on that car.
That leads me to the next obvious question: is how much adjustability did you have in the package to change that balance? Have you got adjustability in the front and the rear, or is it just all focused on a rear wing adjustment?
That one, we could almost do whatever we wanted. The rear downforce is almost no brainer. It's easy to make. Just more wing, more angle. The front's harder because you have to deal with cooling and whatnot, which car one, was terrible. We learned a lot. Basically, I mean, in essence, we did not have enough exit air after the radiators, so it would just build up and it would just overheat. And that may have actually messed with the balance too. If you're choking off the front of the car, it's going to do weird things. But and this comes down to different, realities versus CFD. So basically, I mean, Paul Gerard just drove around it, a little more trail braking, et cetera, and it was fine. So this next car, we spent a lot of time on the cooling side of things, and then also a lot of time on the balance. So.
All right, so that leads nicely into the second car. What sort of changed? Why did you decide to build a complete new car versus continue the development on that first chassis?
Well, car one went away. I crashed a business and had to sell it and try to recoup and lick my wounds. So I did. The new buyers, they tried to run the car the next year. They just ran into a ton of problems because it's not an easy thing to do. So I would have probably done another car anyway. And that was kind of in my plans. Just leave that one alone. It could be the trainer or whatever. Well, then I had to sell it. Car two, it needed a sequential gearbox, period, in order to be competitive. So that was designed around that. I think 2018, I built the chassis, the front chassis of car two, and then I did it responsibly. I just hung out and I just did a bunch of, the body work that I knew it could do because I already had the molds from car one. And then until I had a budget, which happened late 2020, I just kind of hung out and did it as a hobby, just to keep things going.
Let's actually step back one notch here as well. So obviously you've just mentioned you sort of backed into a corner and sold that first chassis. So when you've come out of that, you've obviously run the car with some success, albeit some problems. I'm guessing from the amount of time you ran the car, you're able to kind of assess the strengths and weaknesses of that package as it lay. You've mentioned already the lack of sequential gearbox with the Porsche transaxle, so obviously that's a no-brainer weakness compared to a proper sequential transmission. But what other strengths and weaknesses did you kind of see from that version 1 car?
Well, the braking was absolutely perfect. That was RPS carbon brakes. Everything was beautiful. And then we used Palatov uprights and center locks on the first car. It was great. I'm like, okay, well, let's design car 2 around that because it's a proven component, right?
Yeah, makes sense.
except reality that keeps coming up. So
yes.
Car 2, it may be in conjunction with the sequential box. It may have been an actual, component manufacturer problem. I don't know. We could not keep the rear wheels on the damn car.
Okay, that's definitely a problem. Those want to stay well and truly attached at all times.
And we didn't know it until we were at Pikes Peak. So,
yeah, and this basically cut your run incredibly short from what I recall.
Yeah, the actual race day, I think he hit third gear and it was done. Thankfully, because he was able to just pull over and no incidents, whatever. But effectively, the center lock snub nose, whatever you want to call it, they don't appear to be heat treated properly in this car, and that kind of explains everything in retrospect that we fought with this year.
Must be incredibly frustrating after the effort that's gone in by so many people, though, to be sort of sidelined with a relatively simple problem like that. Yeah, it was beyond. I mean,
simple solution would have just been to bolt some five lug wheels on because we're using a Corvette wheel bearing, but HRE did such a great job on the wheels and lightening them that they had too many holes in the backside, so we couldn't just drill new lug nuts. So basically, we were kind of fighting a braking problem where in a long straightaway we would lose all brakes.
Okay, it was not good.
Yeah, that's lovely, isn't it? So we kind of determined that it was a version of pad knock related to flex in the center locks. The wheel would lift off the actual wheel bearing surface, and so with the rotor, and when the rotor lifts off, the pads move. And that was kind of attributed to the fact that I don't think those center locks were strong enough because they weren't heat treated properly.
I'll just kind of touch on that because a lot of people may not understand that term pad knockoff. So essentially what you're talking about there, that flex in the hub, the upright, is allowing the rotor to move in relative to the caliper. So what it does then is it pushes the the pistons back into the caliper. So then when the driver gets on the brake at the end of a straight, all of a sudden the first hit on the brake pedal, instead of pushing the pads against the rotor, is actually used to push the pistons back out and get the pads back in contact with the rotor. So you end up with an incredibly long pedal, which from the driver's perspective is damn terrifying, right?
Yeah, it's damn terrifying when you're, coming into a corner at 150 miles an hour and it's a hairpin. So Paul Gerard, I mean, he was beyond frustrated. I'm like gutted for the guy because, it's, you just don't want to do that to a world-renowned driver. But
sure, yeah.
So after the race, he's just kept fighting the brake pads. I'm like, fighting the brake pedal. I'm like, there's just something we're missing it. We hadn't figured this stuff out yet. So I finally took the car out after Pikes Peak. I went to Honda meet in Michigan here, and I figured it out. Just as long as you keep, doing the left foot tap on the pedal down the straightaways, it was fine. So it's like,
yeah,
it's we're like, it's got to be a bleeding problem. It's got to be something simple, something. And then that just confirmed that if you, kept jamming the pedal down, it would, you'd have great brakes. So,
and I mean, it's a technique we do see professional drivers adopt. Quite often, if you're watching in car, and you will see at the end of a long straight or coming up to the braking zone, the driver, while they're still at wide open throttle, will just gently tap the brake with the left foot, and that's kind of just to give that confidence, knowing that the brake pedal is firm. So when they do get on the brakes, it's going to respond. But also, if there is any pad knockoff, it's going to take that up. So you've got that firm pedal when you need it. But ultimately, it's obviously a sign of a more serious issue.
Yeah, exactly. So actually, the supercar guys, they're going to be assisting me with some CAD design. Sebastian's way too busy with F1, and I can fumble my way through CAD, but I'm not going to design a full upright system my first go. So this weekend, actually, we're wrapping up design on the new uprights, which are going to be, I don't want to spill too many beans. The base design is off of an existing Le Mans car that has success at Le Mans. So Le Mans, however you say it.
So just in terms of CAD, like that was another question I had for you. Obviously, when you're designing a clean sheet of paper car design and it's going to be tube framed, getting everything in the right place, making sure that you've got room for everything and it's all going to be packaged properly. There's a big challenge there. There's a lot of stuff to kind of nut out and make sure it's going to work. Were you using CAD for the modeling of the car, or was this kind of just hand built as you went?
For the most part, hand built.
Okay.
I mean, you build turbo kit. Turbo kits to me is kind of the ultimate fabrication thing, and chassis work and roll cages are too. But turbo kits, you really learn packaging, and so you kind of step back when you're doing something like this. I don't think I actually wrote anything down. I just kind of stepped back and envisioned where I was going to put this. Where am I going to put the dry sump tank? Where am I going to put the fuel cell? Obviously you get into something like, oh, well, that hits. Now what? You just got to deal with it and you got to move it. So.
And that's been the same for the Gen 2 car up until now. You've said you've got supercar systems helping you with these uprights, but basically same deal. It's just being built by trial and error, hand. For
the most part. So the second car, in that time span, we did get the front chassis, I guess the tub, driver's cell, whatever you want to call it. We do have that in a CAD now, so we do have a full car CAD model. So I was able to more or less kind of fumble my way through, drag, the Gearbox model that Sadev sent us. Supercar system, at the time, they weren't my employer, they were my sponsor. They supplied us with a CAD model of the engine, so I was able to kind of drag it all in, kind of connect the dots. Did I have a finished, polished, FEA ready CAD model? No. But I was able to determine where it fit and what measurements to go off of, say, off the firewall, because that's a known thing. Kind of did that. And I mean, I just triple check measurements. I'd get halfway through mock-up of certain things. The wheelbase. Yep, still lines up. All right, keep going. So, and that's kind of how it went.
All right, so there's a couple of other things that you've sort of talked about so far that I wanted to dive back into, because one of the questions that we obviously always have to consider when we're fabricating components is what size material to use. So, and you've mentioned that you struck a few problems with that Gen 1 car with the likes of the pushrod failure. So what's the process? Obviously, if you've got something that's 3D modeled and you understand the forces that are involved, most of the current packages, SolidWorks, Fusion 360, etc., will allow you to do FEA, finite element stress analysis, and basically validate that a component such as a pushrod is going to be up for the loads involved. Which to me, this is definitely not something that I do. It's out of my realm of experience. So I'm not talking from first-hand experience here, but I mean, on one hand, that sounds great because if you do that all right, then you know from the get-go that, yeah, I'm going to have the confidence that pushrod or that wishbone or that upright is up for the task. It's going to do the job and it's going to be safe. But of course, it is very much a case of garbage in, garbage out. So if you don't have a full comprehension of the loads involved and you can't put the right inputs into the simulation, well, of course, the output is going to be potentially misleading. Now, you said you didn't do that because you're not doing that 3D modeling at that point, but what is the sort of fallback option as a fabricator if we want to make a wishbone, a pushrod, a component? How do we decide what size material, what thickness, what wall thickness, what size rod ends, what size fasteners that need to be used for that application to ensure safety?
I'm trying to think back to what I started with. I think what we determined what caused our failures was we didn't take into account the horizontal angle of the pushrod. So a pushrod straight up and down will take a lot more load than a pushrod at, say, a 10-degree angle. It's just the physics of it, and it increases the load going through it like a multiple factor. I don't even know. So that's what happened there. So we basically doubled the OD. I think we're running inch and a half pushrod, inch and a half OD, and I think we ended up doing a 0.095 wall thickness. So they're quite substantial on this car. As far as, what size should you do everything, I don't have an answer as to what you should do. I can share what I did.
Yeah.
In this case, I mean, half-inch rod ends were abundant. They're definitely beefy as heck. And then as far as tubing thickness, I'm trying to think. So the control arms on the first Enviate were just round. They weren't aero tubing or anything. I think there were 7/8 OD, and I think I honestly went through with what I could get at the time for weld inserts to thread to the heim joints. I think we did 083 on those ones. I know we could probably get away with 065 just because...
And when you say 083 and 065, you're talking wall thickness here.
Wall thickness in inches, sorry.
Yes.
So
no, it's okay.
I don't even know what that would be. What would it be? 2 millimeters, 3 millimeters? So, so I mean, something like this, I try to err on the side of a little heavier because it's somebody's life, multiple people's lives at stake.
Definitely.
So if you're going to get into that crazy, then you do have to get into the 3D modeling. You have to have experienced CAD people doing the modeling that know what forces are. Like you said, garbage in, garbage out. So if you're just building your own stuff, I just go heavier than you think you need just to try it, just to prove your concept and kind of go from there. So
I think this is a question I hear come up time and time again, and I think particularly with the prevalence now of 3D modeling and finite element analysis, people think that is the only way to get a safe result. And of course, that's not the case at all. One of the techniques that I've used in the past, and I'm definitely no master fabricator, but I've built my own components and I've worked with my in-house fabricators over 20 odd years now. So we haven't done anything to the level of what you're doing, but you still want to know when you're designing a component that it's going to be up to task and safe. And a really good way of at least getting a feel for where the ballpark is to, in my opinion, just walk around a local race meeting in the pits and have a look at other cars of a similar weight, size and design to what you're trying to build, and just physically have a look at what those cars are using. And I think, within reason, you're generally going to get a pretty good guide on the sort of size of rod ends and fasteners and control arms, etc., that these cars are using. If it's a proven concept, it's a proven car, then obviously that's going to be a substantial starting point, rather than trying to absolutely guess or go through a whole lot of engineering calculations that may be beyond you.
Yeah, I agree. One thing I will say is when I do the paddock walk, I'm amazed at how small some of the fasteners and heim joints and everything is on those cars.
Yeah.
Just because it just makes me nervous. I don't know. I have a hard time trusting just because I've broken so many things. Not going to name names, but I've had fully FEA, blah, 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 cars break in the parking lot, like rolling out of the shop. It's just like, and whether it's a design issue or a final, finishing issue, it doesn't matter. It broke and it shouldn't have, basically. So that's it. You have to have some intuitive, learning about it, I guess.
Yeah, I mean, I think when you're looking at some professionally designed and built race car components, particularly open wheel stuff where weight is really such a critical component of it, then the designers are going to extreme lengths to minimize every single gram that they can. I think for most of those people listening to this podcast, it probably at a guess they're probably not working in an F1 team, and I always think that if you have to weigh up a few extra grams of weight for a stronger component, most often the extra weight's probably going to be worth it for a little bit of additional strength. So that's my trade-off. I prefer safety over the minimal weight every single time. But of course, in some formulas, that's just not going to cut it. And you can build a nice, safe car that's going to be extremely slow, and no one's probably going to be super stoked on that either. So it is a balancing act, I think.
Yeah, that's true. And I guess same thing goes with composites layups, like wings and things. I know the front wing on the last car took a beating, and you could tell. So on this car, I mean, we built the wing. At the front wing, let's see. The first car, we had to add a bunch of tubular reinforcement internally in order to get it to be stiff enough. And it actually ended up being quite heavy. So this car, we ended up, we learned a lot in the last 6 years, so built it up pretty crazy. It was probably about the same weight, but I can tell you it's a lot stiffer. I mean, you can stuff 3 guys on the end of what would it be, 3 meter wing almost. It's just under 3 meters, and it'll only deflect about 10 millimeters. So
yeah, okay.
So it's like, okay, we can make it lighter, sure, but how much deflection are you going to get? Is it going to last more than one impact with a hairpin? Where you have a 20-degree rate increase.
Yeah, I think that's something that's easy to overlook when you're building components like that. The forces again involved, particularly with aerodynamics. If it's designed right and it's producing huge downforce at high speeds, then yeah, you've got to take that into account when you're designing it and make sure that it is physically going to be up to the task. Now, you've talked a little bit about the engine in the new car, so this is quite a departure from the old junkyard 5.3 that you had in the first car. You mentioned supercar systems have come on board, so talk to us a little bit more about what went into the engine combination there.
Okay, so a supercar system, I mean, their company goal is to have complete cars for sale. Can't get into too many specifics because they're not my employer, but what they have coming together is fantastic. But the basis of what they're doing is their engine program, which if you go on their website, supercarsystem.com, it's singular, no S, system. Okay. You'll see several of the packages. They outsource the engine work to Steve Morris Racing Engines, who's actually just an hour and a half away from my shop in Michigan. He has some of the craziest engines on the planet. I think he was involved with the Devil 16. The list goes on. He's done a lot of cool stuff. So this, the engine that went into this car, into the second Enviate, was it's a 427 LSX based, but it uses some proprietary, say that 10 times fast, Components inside, the supercar design and such, makes ridiculous power. I mean, at 7 or 8 pounds of boost, it's somewhere over 900 horsepower at the wheels. I don't know. I used a Mustang dyno at my Michigan shop, and I could never get a good reading on it. I had no idea. Yeah, so LSX based, 7 liters. Just it was a nice departure from the junkyard days.
Ultimately, what sort of power, even if you couldn't measure it, what sort of power is the engine rated to handle, and where do you kind of think that you got to with it?
The turbo on this car, single turbo, it's a Garrett G42 1450. So figure it'll do about 1,500 horsepower somewhere, right? The engine itself will make, it's an LSX. It'll do 2,500 horsepower plus if you wanted it to. Okay. It's not going to do that on that turbo. It's not going to do that at Pikes Peak because there's just not enough cooling. So funny little tuning thing. That's the first time I've seen this. But up at Pikes Peak, with a single turbo smart 60 mil gate, it would hold 7, 8, 9 pounds, no problem, just off wastegate. We brought it down here to do some testing. I couldn't get it to make less than 20 pounds.
It's funny you should say that. The car that I was involved with at Pikes Peak, we tuned it here in Queenstown, which is maybe 1,000 feet above sea level. So for all intents and purposes, let's call it sea level. And that was great. We were running 20 psi of boost, and it was all in by about 3,800 RPM. And when we got to Pikes Peak, initially I thought something had fallen off. We had a massive boost leak because it was so laggy, and the boost was down, as you say. I mean, it's a steep learning curve understanding the implications of that low air pressure at sort of 14,000 feet.
And that's a reality thing too. You can model all you want until you get there. You have no idea. You don't truly know. It's kind of funny you say that. 2012 was the first year I went up there with my NSX. It was a 3-liter Honda V6. We had a GT42, so roughly the same size turbo we have now, but with half the engine. So yeah, same thing. We were running 4,500, 5,000 RPM peak boost, which at sea level was great. I mean, that engine revved at $9,000. So we get up to Pikes Peak, and it didn't even come to live till like 7,000 RPM, 7,500 RPM. So I was like, well, that sucks.
It's not much of a power band.
So that kind of led my journey into the whole V8 thing, and V8, which was NSX V8. So yeah, I just went with a bigger engine. And this last year we brought the biggest one yet. So. Yeah, so we brought the car down to sea level, and it was running we only had a single gate on there, and it wouldn't run less than 20 pounds. I'm like, all right, send it. So this was at Honda meet, and we'd figured out the wheel issue by then, so the wheels were staying on. Still had the pad knock issue, but I just drove around it, and I wasn't going for outright lap times. I wasn't comfortable even getting into the car that much, but. I mean, I drove the car at 20 pounds. What's 20 pounds in a 7-liter at sea level? That's got to be 1,400 horsepower. So
you'd have to be there or thereabouts, surely.
So, but it was ridiculous. I know turn 1 at Gingerman, it's kind of a drop, like a little bit of a G out load turn, accelerate out of type thing. It was lifting the inside front tire. The car was basically almost trying to do a wheelie. I mean, not really, but the inside front tire was lifting, so it was pretty wild.
All right, so one of the obvious changes there with that engine combination, you've gone from the 5.3 to the 7-litre, but at the same time you've gone from twin turbos on the original car to now a single G42. Can you talk to us about the reason behind that, pros and cons of twin versus single turbo?
In this car, I mean, the whole focus of, the first car I thought was fairly heavy, so I was trying to get the weight out of it, out of this car. So yes, one turbo is always lighter. You have one wastegate, etc. The intercooler package of the supercar system intake manifold was another reason. Trying to plumb 2 turbos, like the first Enviate, each turbo was kind of on the ground in front of each rear wheel. So you've got how many feet up to the throttle body? You got over 1 meter to the throttle body, and then if you add additional cooling, trying to go through intercoolers, you got 40 pounds, 20 kilos of extra weight just chilling just to even connect the air. So in this case, we have one little, not little, 100 millimeter pipe, tube that goes from the turbo to the throttle body. It's about maybe 1 meter long total. And intercooler's built into the intake manifold, and it's just super lightweight.
So you're water to air here now.
Yep, yeah, water to air in this one. And then 2012 on the NSX, it was also water to air. And that thing cooled fantastically. So, and one benefit to water to air is you can put ice in it at the start line. So you can actually run sub-ambient if you need to. We didn't this year, but we could. So
I'm guessing for a hill climb the length of Pikes Peak, that probably becomes a bit of a moot point ultimately. Would that be fair?
That, and I think it was actually decently cold this year too. I think it was only, I don't even know where, I'm not going to begin to convert to Celsius for you, but it was about 60 degrees Fahrenheit.
Now, one of the other things we talked about the boost response issues with Pikes Peak, and I mean, I was going to Pikes Peak well aware that I was going to be expecting a decrease in power. That I think everyone probably can kind of get their head around that. We've got probably 60 to 65 kPa barometric air pressure at the top of Pikes Peak. So yeah, you don't have a lot of density there, so that's fine. But the bit that kind of maybe blindsided me, and in hindsight it's completely obvious, is you've also got less air density or air mass to cool your radiators and your intercoolers. So basically a car that keeps itself nice and cool at sea level, sometimes you get it to Pikes Peak, and trying to keep the engine cool and keeping the intercoolers working can be as big a challenge as anything else. So is it you've built this car with the intention of going to Pikes Peak? Is there anything specific you did around the cooling package to make it live at Pikes Peak?
Oh, tons. I would say the bulk of the engineering on the second Enviate was related to engine cooling. Manuel Greiner, he's also of Alfa Romeo Sauber. He hopped in with Seb and helped just kind of run design on the cooling package. If you look at the pictures of the first Enviate, you'll notice the side pods are a lot different. The second Enviate, we have side exit radiators, and basically it just comes down to the angle of attack on inlet and outlet on the radiators and getting the air out of the car. Also, the rear of the car, there's substantial ducting out of the car. We did a new engine cover on this car. The second car has a nice snorkel above the cab, like a Le Mans car. The air filter stuff's right up in there. And then, so that way you're not ingesting hot air. That was another issue we had with the first car. So at sea level, it wasn't a problem, but for whatever reason, I think there was enough density, as you say, it seemed to push the air through the car, but up here it just stagnated. I didn't know it until I got back to Michigan. And when I got back to Michigan after the first Pikes Peak in 2017, I left the car in the trailer for a month. I didn't look at it. So I pulled it out. I'm like, let's see what it makes on the dyno. And the engine was essentially blown at that point. The head gaskets were non-existent. Still made like 750 horse at the wheels, but the air filters were gone. They melted off the turbos. Wow. So
okay, that's not good.
That was kind of fun. That was so we took a lot of steps with that. It designated air intake, and then the engine cover itself has a lot of louvers on it to evacuate the air out the back. And then also at the back of the car, you can't see it from the sides, but we cut the side pods short by about almost a meter short compared to car one. When I say side pods, it's like the rear wheel covers basically. So instead of trapping the air inside, it just evacuates right out on top of the diffuser. The other thing, actually kind of the basis of why I wanted to build a second car anyway, is I built a narrower front chassis. Not suspension wise, but after the suspension on the first car, the cockpit flared out pretty aggressively. On this car, it's very narrow, like a single seater. So we effectively quadrupled our inlet air volume capacity, if that makes sense.
Okay. So you got more air volume without actually needing to make the car wider because you narrowed the chassis.
Correct. So, I mean, each radiator has almost triple the inlet air capacity compared to the first car. So but between that, so I would say this car is an exercise in cooling compared to the first car. Power is easy to make. Sequential gearbox just costs a lot of money, but it's pretty easy strategy. And everything worked. That's a crazy thing. We could go out and lap this thing at 20 pounds of gingerman. I lapped it, did 10 laps, so I ran out of gas, and it never went above 180 degrees Fahrenheit. It did fine up at Pikes Peak, but at Pikes Peak we weren't pushing it, so I can't say it works perfectly at Pikes Peak yet. So
I think the worrying thing with Pikes Peak as well is you only get that one shot at running the full length of the mountain. The test days are split into thirds of the mountain, so yes, it's still torture testing, but you don't get to do that full run. So particularly if you kind of get to the end of a test section and you've only done a third of the full mountain and things are looking maybe a little bit marginal, that kind of you leave that day of testing with a big question mark hanging over what's actually going to happen on race day when you run the full length of the hill.
Oh, exactly. Yeah, it's brutal out there. That's the one bad thing about it. This year, I mean, Paul was able to, he put down a couple of respectable times during the qualifying and stuff. But everything worked on that. That's what's so frustrating, is just something so simple this year was like sidelined us, because everything worked everything worked like it was supposed to.
Yeah, I mean, I think that's the cruel aspect of motorsport, the highs and lows, and it only takes one thing to let the whole package down. So, I mean, fortunately, no real damage done. So you get to learn from that and come back hopefully next year stronger with a wheel that doesn't fall off, and we'll see where you stand. At this point, we haven't really talked much about the suspension package. And I'm interested to know, again, you've sort of mentioned you've built the whole car really without the aid of 3D modeling. But suspension is one of those aspects where just kind of having a bit of a guess at where the wishbone should locate is probably not going to get you the optimal result. So were you using any kinematics packages to sort of design and validate the suspension location for the pickups?
So if we go back to car one, the basis of the whole thing, I spent a couple of weeks going back and forth with different kinematic packages, as you said. I used racingaspirations.com. It's a free website. You can put in your pickup points. You can put in your operate points and move it up and down. You can do all kinds of stuff. It gives you toe, gives you roll center. At the time, it gave you all that stuff for free. Now you got to pay a little bit. It's like $10 a month or something. So the base design, I kind of doodled in with that, and it worked great. Since then, we upgraded to the Palatov uprights, so we had to change a couple things. Not a whole lot changed as far as the base design. I didn't want to go back and change the chassis a whole lot, because if you spread your control arm attachment points more vertical out at the outboard, you'll have to do the same thing on the inboard. Otherwise, you'll get more camber curve. It gets real technical. So car one, we just kind of left it. And it did fine, actually. Paul loved the thing. So car two, I made a couple adjustments. At that point, Eric Streeter, who was involved with the team with car one, he started a business called Speed Street LLC. I was involved with the naming portion, by the way. And so he has a full package, a whole suite that he uses. So he ran the whole thing through. Being that this car used stress member gearbox, the A-arms actually connect to the gearbox. So him and I went back and forth quite a bit to dial in the exact attachment points on the gearbox versus the uprights. Not gonna lie, I mean, I understand the basics, but I couldn't tell you the magic of it, I guess. So I just build it. I rely on my team for that stuff. So
it's complicated for sure. When you're dealing with a stress member gearbox like the SADEV transaxle, are you able to dictate to SADEV where those pickup points are going to be? Normally I see there's sort of adjustability, like there's a few different locations for the upper and lower wishbones, where you're just working with those predefined pickup points that SADEV offer to everyone.
So yeah, SADEV basically, you're kind of locked in on a pad, suspension pad. They offer different hole positions. Then you can do multiple. So we did that. But we did have kind of a magic sweet spot that Eric and I helped dial in. And we ran it like that, and it did fine. The gearbox we used was the same gearbox that the Peugeot ran in 2013. So we knew the box worked. They ran a stress member as well. So that's always nervous, because if you take a gearbox that's not designed for stress member and you're putting that kind of load through it, I mean, the whole back of the car would just break off. So
does the rear wing load onto the gearbox as well, or is that being supported directly into the chassis?
Oh no, yeah, it loads directly to it. Everything does. So
okay, so that's a lot of force.
Yeah, what I did, I built kind of I extended the chassis a little bit, if that makes sense. So I'm not relying purely on the gearbox. I had to support the rockers. The rocker bearing cups are tubular and they're fabricated. So you've got a little cage, quote unquote, that bolts to the top of the gearbox.
So you're talking the rocker here for the push rod suspension actuation?
Correct. Yep.
Yes, okay.
So yeah, it's the rocker bearing, whatever you're going to call it.
Yep.
So there is a small tubular structure that bolts to the top of the gearbox, that fastens from the rear of the gearbox forward to the chassis. That way the gearbox is definitely still stressed, don't get me wrong, but I wanted to share a lot of the load with the actual chassis. So going forward, while we're on the SADEV gearbox thing, SADEV does have a new gearbox. We're going to be using it. It does have integrated rocker bearing cut posts, whatever you want to call it. Okay. So we'll be doing that, and it will be fully stressed. And this one will be all-wheel drive. But that's, like I said, we've started a third car, but we're not going to try to push for that car to be done for this year's Pikes Peak. It's just too much. So we're going to refine this car with new uprights, and there we go. So
now further into that suspension as well, just looking at the photos that you'd posted up as the car was being developed and built, you're running a heave spring from what I could see there. Can you explain what that is? Third element, it's also referred to as well, just depending what lingo you want to use. But yeah, what is that, and why have you got it incorporated?
It's called a third element or a bump spring. I mean, you call it whatever you want. Everybody calls it different things, but yeah, that was another basis of the design of the first car. Was I wanted a way to transfer the aero load to a designated damper. That way you could run the corners soft, because you've been to Pikes Peak. Well, when's the last time you were there? 2017?
18 maybe, but a while back. But I guess it's probably no smoother than it was when I was there last.
Exactly. I think 18 they did a bunch of repairs, but it's gotten pretty rough since even 18. So it's rough. Yeah. I mean, picture you going on a highway and you hit a bridge overpass with the 6 centimeter gap. You feel it. It's huge. It's a big jump. Yeah. So
I think for those maybe who aren't familiar with Pikes Peak, one of the problems they have with an asphalt road at that altitude, which is probably, I'm guessing, why it was dirt for so long, is that you've got snow and ice up at altitude, and basically the water gets underneath the asphalt, and then overnight it freezes and it expands, so it pushes up the asphalt. So from what I understand, I mean, I've only driven a road car up Pikes Peak, but they'll seal the road and it'll be perfectly smooth, and that year's running of the Pikes Peak hill climb is great, because the guys get a fresh crack at a nice smooth road, and then 5 years later you're kind of running over just about off-road jumps, just sort of it's that rough because of all of that lift. Yeah,
it's insane. I mean, it's to the point where, I mean, if you run a trophy truck up there, you'll probably be faster through the trophy truck and the rough stuff than you would any kind of car. So I mean, the option is, close your eyes and grit and power through it and bounce around, or you have to lift. So
yeah,
and that was the basis of what I was trying to avoid. Like the Enviate runs a fairly high ride height. I want to say it's 150 millimeters in the rear and 100 millimeters in the front, static. I mean, granted, you get into the suspension, it's quite a bit lower, but a circuit car, you're going to set up. Take 100 millimeters out of that. So most circuit cars are 20 millimeters front, 30, 40 in the rear. It's pretty crazy.
So let's sort of dive back into that a little bit. So, the first thing is with anything that runs, developed underbody, aero, big diffuser or tunnels or whatever, the effectiveness of the underbody aero and the front wing for that matter is going to be very dependent on the ride height, and within reason, you kind of want to run them as low as you can. But of course, the problem with that is that the downforce increases with speed. So if you start with 100 millimeter ride height static and then you get up to 120 mile an hour, that all of that force is pushing the car into the ground, so your ride height drops dramatically. So your solution there is to either run very stiff springs, which will keep the car off the ground at high speed, but then affects your mechanical grip in low speed corners because the individual corners of the car are really stiffer than is ideal. Or alternatively, you run this third element. That's sort of a good sort of overview of how that works.
Yeah. I mean, the third element only activates when both wheels move at the same time. So braking, accelerating, or overall pushing or lifting, I guess, if you want to look at it like that. So yeah, that's an effective way to keep the car off the ground while still keeping the corners soft. So.
In terms of the validation and development on the suspension, was that something that kind of just worked straight out of the gate and was good to go, or did you need to do significant work on spring rates and damping, etc.?
It was actually pretty darn close.
Okay.
That was just pure luck. There was no real thought. It just kind of ran off that. We did make a bunch of changes at Pikes Peak in 2017. This year, it was, we just kind of took what we learned and applied it, and it was right off the bat. I mean, that was a whole team effort. I mean, they ran it through, Eric ran it through his stuff. But this year, if you want to know what we added? Shock pots.
Okay.
So we have real data. It was amazing.
So you're not guessing now.
We're not guessing. So, yeah. So, we were able to kind of verify some balance numbers and all that based off motion ratios, and it was pretty cool.
Yeah, a lot of great data can come from shock pots, that's for sure.
Yes, exactly. Interestingly enough, I'm never going to remove front downforce, but we can tip up the rear wing a little bit based on the last test we did.
Interesting. All right, so you're at a position now where you've got, we're November at the moment as we record this, and you've got, I even forget, I think it's June is Pikes Peak. So you've got essentially 6 or 7 months to kind of iron out the remaining bugs. You've mentioned new uprights. Any other changes that you're planning for the car before it runs next year?
Nothing. I mean, it's literally that good. That's why it's so frustrating this year. I'm concerned about actually getting invited this year. If I'm being candid, because I mean, nobody wants a car with a wheel that can fly off. But I mean, the car is pretty darn well developed for what little time I had into it. Being that I moved to Las Vegas, the Supercar System factory is across the road from Las Vegas Motorsports Park, or whatever, the big place where they run Top Fuel. And I think there's 13 tracks that we can run on. So,
oh, wow.
Yeah, we'll be spending a lot of time there.
Testing.
Yeah, year-round testing. And it's hot. It's hot as hot can get. So if we can get the car to run here successfully, I think it'll do fine at Pikes Peak. So our focus is on the uprights and then just testing. So we're gonna fly Paul out here quite a bit so he can get acclimated to the car even more. And so this year, I mean, it's just complete new corners of the car, but the concept's fairly simple. The rest of it seems to work really well, and got to get a bunch of testing in.
Okay. In terms of the last couple of years at Pikes Peak, you've got the outright record held, I think, if my memory serves correct, still by Romain Dumas in the Volkswagen EV. We've got Robin Shute, who's not too far behind. Where do you sort of think that the car could fit in terms of outright numbers up there, outright times?
I think in rear-wheel drive, optimal will be low 8-minute range.
Okay, wow.
So we'll be right in there with probably Robin Shute. It was funny because Robin Shute and I shared a shop this year, so we were all in there. It was a cool atmosphere. We were at 40 Engineering. Calder they ran the Evo. Well, same place we were at when you were in 17.
Yeah, it seems like that's the place everyone hangs out.
That's where the cool kids
all the teams go there. And it is a good environment. Everyone's sort of helping everyone else and trying to get the cars running.
No, it was great. So Robin, they got some of their suspension stuff wrong. They chewed up a floor. So my carbon guy, I mean, he'd done his job. The car was built, but he had no racing experience. So he's kind of chilling out. So he ended up fixing their floor. I mean, it's just with Pikes Peak, you're not, trying to stab the racer next to you. You're helping each other get up the damn hill.
Yeah, absolutely. Yeah. Yeah, it is a nice friendly environment, which is a nice way to be involved with motorsport. Everyone's pretty friendly and chilled out, which is pretty cool.
Well, and it helps the newer people to the sport that have no real motorsport experience. It helps them learn and grow as people. So it's pretty cool. But back to the times. Yeah, it should run low eights somewhere. It just depends on how good of a run we get. I mean, theoretically, the thing will run like 730 if we put it into a calculator, but we all know reality. So,
yeah. I imagine you'd be probably pretty happy with a low 8 minute.
Yeah, I'd be happy with anywhere in the eights this year for sure. And then all-wheel drive, that's a whole different story.
All right, Cody, look, we'll start to wrap things up here because we want to respect your time. Obviously interested to see how things do go next year, and hopefully we'll keep our fingers crossed for you that the bad luck is maybe done and dusted. What's next for you? Obviously, you mentioned your new position at Supercar System. What do you sort of think the next 18 months, 24 months is going to bring for you?
Well, I've been kind of put in charge of an entire line of vehicles, so
okay,
no pressure. But Supercar System, they were founded in 2014. Team of great engineers, not many builders. So that's where I come in. So
sure.
They've just moved into this massive facility. It's the whole factory is 170,000 square feet. Supercar System does not have the whole thing, but I think we're 17,000 square feet. So the focus is going to be to get the cars up and driving. They're probably what's going to be their most popular product is their gearbox. They've designed a gearbox from scratch.
Oh, okay.
And it is amazing. It's a transaxle designed for an LS, but it does have an interchangeable bell housing, so you can easily swap out. Can't say where it failed, but it was well north of 1,500 foot-pounds of torque. And most transaxles are not rated for anywhere near half that. The reason they did that is because of their engine packages. Their next engine package to be revealed is their billet stage 5, which we will have in the Enviate at some point. That's, basically a pro mod with water jackets. It's going to be insane. 3,500 horsepower is not going to be a problem with that thing. So that's why they should
be enough to get you up the hill.
Let's just say, again, we only have 1,200 horsepower worth of cooling in the car, but it'll do it at like 7 pounds of boost. So my job is to get the cars done, get them running. They've got bodies designed, they don't have them built, so that's where I come in. And I don't want to say exactly what we're doing, but it's going to involve a highway out of power ump as soon as we get the cars up and running.
Exciting times ahead.
Absolutely. And then obviously Pikes Peak. So part of my employment there is a separate 3-year contract with Enviate at Pikes Peak. So we've got 3 more years at least.
If you could give advice maybe to a younger version of yourself, maybe to fast track the path through the industry that you've had, what would you suggest?
Don't be afraid to ask questions. Try to be humble. It's hard in this world of look at me.
It is.
Yeah, just research YouTube. If I would have had YouTube back then, that would have been insane. And the next thing, don't be afraid to go to a shop and say, hey, I want to help. That's probably going to get you the most real world experience. My current, it's sad because, I have a great crew in Michigan. And in fact, I'm not closing the business, but I'm closing that physical location. And the team I have there is fantastic. And one of them was a certified welder. The other one didn't know how to change his oil. And Connor, he's the carbon guy. He built the whole car out of carbon. He just showed up one day and I put him to work and he learned, and there you go. You got to start somewhere and just dig in.
Definitely. All right, we'll get you out of here, Cody, but last question for today. If people want to follow this journey, where can they find you on social media or anywhere for that matter?
Well, I'm going to keep kind of tabs on my personal journeys with all of this. Instagram is probably the easiest way, Cody Loveland Racing, and then Enviate Hypercar. And then for the supercar stuff, I'm going to be covering a lot of that too. I think Supercar System on Instagram is probably the best way, and then you could get all the websites from there. So
Sounds good. All right, Cody, we'll get you out. Thank you very much for your time. We appreciate it. And again, we wish you all the best for Pikes Peak next year. Let's see if you can keep the wheels on the car and actually get a representative time up the hill.
All right. Thank you so much for having me again.
All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.